we're now going to move into seeing how unit analysis can be used in situations where we're trying to perform conversions, but we've got multiple unit labels going on at the same time rather than just a single measurement. So in this particular scenario, we're looking at stacking up the speed of 70 miles per hour with that of 80 feet per second. So we do have this situation where miles is being related to hours. So you do have multiple units going on right here. So ultimately, if we want to try to solve this problem, we're going to want to compare these. And to compare these, you're going to want to probably convert the miles per hour into feet per second, or you can go the other way as well and convert 80 feet per second to see how fast that is in terms of miles per hour. And we can do that exactly using the technique of unit analysis. I'm just going to go in this direction. So I'm going to start off in 70 miles per hour. Now, when we're given 70 miles per hour, the per is really saying that we've got a ratio or a fraction. So it's like 70 miles divided by per hour. And when it says per hour, that's a single hour. So I'm going to put a number there as well. That's 1 hour. And then really we can just use the same sort of stuff we were doing previously with unit analysis and just multiplying by conversion factors. Really just multiplying by 1 a bunch of times until we get where we need to go. So by the end of this, we're going to convert miles per hour into an equivalent number of feet per second at the very end here. So in order to do this, really all you need to do is just convert miles into feet somehow using the appropriate conversions to do so. And then separately, after you've done that, then you can just convert hours into seconds. And that's all that's really involved. So let's just worry about the red part of this first. So you're going to need to know the conversion or conversions you need to progress from miles to feet. So the number of miles, that's equal to the number of feet. If you don't know it, you can look it up. It turns out that 1 mile is equal to 5,280 feet. And then that would be all we would need to do to take care of this red part of the problem. So I'm just going to multiply by a fraction. And what I'm trying to do here is I'm trying to cancel out the miles there. So I'm going to have to put miles on bottom. And we're going into feet right now. And then put the numbers where they appropriately need to go. So 5,280 feet over 1 mile will be the conversion factor that we use. We'll multiply by that. All right, so the mile labels there are going to cancel out. And now we're in feet, which is exactly what we're trying to get into. So we're good with that aspect of the problem. So to kind of finish up the last part of this problem here, we're going to change from per hour into per second. So if you want, I mean, you can go straight from hours to seconds if you know the number of seconds into an hour. It's actually 3,600. The reason why that is because if you went from hours to minutes and then from minutes to seconds, there's 60 minutes in an hour and 60 seconds per minute, and 60 times 60 is 3,600. So however you want to do it. So you could go about it like this. Since I have hours on bottom to start with, you got to make sure that you have hours on top then there to cancel them out. Then I put 1 hour. And then if you were to say, let's go to minutes, then you could put minutes and then put 60. And then you'd have to multiply by another fraction. So what would have happened at this step is we would have canceled out the hours there. So now we're in minutes, but then we'd want to cancel out the minutes on bottom there. So I'd have to put minutes on top and then seconds on bottom, and 1 minute is worth 60 seconds, and then you get the minute label to cancel out, okay? So you do see you get the 60 and the 60 on the bottom, and 60 times 60, like I said, would be 3,600. So if you had wanted to do so, you could have just put a fraction here and put 3,600 seconds is equal to 1 hour, and then you can see that the hours there would have canceled out with the hours there, and then you'd be straight in seconds. So either way you go about it is just fine. So I'm just leaving it where it's at right now. I'm going to take 70 times 5,280 times 1, and all right, we're going to need a calculator for that. It's going to give me 369,600, and it's in feet. Per, and then 1 times 3,600 is 3,600, and that's in seconds right now. And then I'll just divide that. It's got decimals that go on forever. So our final answer, it's got 102 102 point, and then it's 6 repeating, so I'll write it exactly like that. That would be the number of feet per second for, I guess what we started with was 70 miles per hour. All right, and then that would allow you to, of course, then convert or compare this to the 80 feet per second, and clearly the 102.6 repeating is a faster speed, so 70 miles per hour would be faster. All right, I'll just do kind of one more example, pretty similar to what we just saw there, and then I'll end with one last example that's just kind of some special cases. Just gives you some more examples to work off of in terms of using unit analysis to be able to convert rates. So in this particular problem right here, dealing with the Mississippi River, there's 436,000 tons of sediment that flow from the Mississippi River up into the Gulf of Mexico every day. So assuming this rate continues, how many pounds of sediment is this per minute of time? It'd be interesting to know. Probably going to be a lot if it's 436,000 tons, right? That's per day. Just come out to be a lot per minute. All right, so we're just trying to do a conversion here, right? We're trying to take take 436,000 tons of sediment, but that amount of sediment is how much goes into the Gulf per day. So I'll kind of write that as this, because it'd be that rate there, and we're trying to get this into pounds of sediment per minute. So I want to be able to get to pounds per 1 minute of time. So similar to what we had before, we'll want to convert tons to pounds somehow, and then also convert days into minutes. So you'll want to know what the conversions are to get you from tons into pounds. Look it up if you don't know. There's 2,000 pounds in 1 ton. So we're going to multiply by the fraction to cancel out tons. We'll have to put tons on bottom, and it's 1 ton is 2,000 pounds. Excellent. And then we're now in pounds. And then we'll just kind of focus on converting the days here. So I'm going to multiply by another conversion factor. Since days was on bottom to start off with, and I'm going to put the label of days on top. And we're trying to get to minutes. So let's go from days to, I suppose, hours, since we do know that there's 24 hours within 1 day. And then I'll get the days to cancel out. But then I'm going to need to change hours. I'm going to multiply by another conversion factor with hours on top. So I get the hours to cancel out. And then we can go from hours to minutes, because we know that 1 hour is worth 60 minutes. And then we're good, because then the only labels that are left are pounds and minutes. So then our math that we can perform here is to take 436,000 times 2,000 times 1 times 1. And so on top, that would give me 872 with 6 zeros, so 872 million. And then on bottom, I've got 1 times 24 times 60. You multiply that out, that's 1,440. And that's in pounds per 1,440 minutes. And then you can divide those two quantities. And that's going to give us our final result. So this would be 605,555 point, and then it's 5 repeating, it looks like. So 0.5 repeating. There we go. And that would be the number of pounds per minute. That's a lot of sediment to go into the Gulf of Mexico just from the Mississippi in a minute, right? Every day. Pretty incredible. All right, and then the last example here, I just kind of want to make you realize just kind of some special cases of converting rates here. So a particular maple tree tap yields 5 fluid ounces of sap per hour. What is this rate in cups per hour? And then the second question, fluid ounces per minute. So kind of just 2 separate questions right here. So I'll kind of do the first part of it on top there and the second part below that line that I just drew. Okay, so it's yielding 5 fluid ounces of sap per hour. So that's telling us the speed at which that's going at. So 5 fluid ounces per 1 hour. And we want to get this into cups per hour. So cups per hour is what we want to convert to. So what you're going to recognize here is that the hours aspect doesn't have to change. So we don't actually have to worry about converting that aspect of stuff. We do need to change fluid ounces into cups somehow. So you'll need to know the conversion or conversions to do so. What we'll want to know is that 8 fluid ounces is equal to 1 cup. And that's all we would need to use. So just kind of one conversion factor. So I'm going to multiply by a conversion factor to try to cancel out fluid ounces, where then fluid ounces on the bottom of that conversion factor, and then cups will be on top. We know that 1 cup is exactly 8 fluid ounces. Okay, so the fluid ounces cancel out, and then we're good. So it's really just 5 times 1 on top and 1 times 8 on bottom. So it just gives you 5/8 cup per hour then. And then that's it, right? So that gives you your final result. And then in the second problem, we just need to convert to fluid ounces per minute. So kind of resetting ourselves here, this is 5 fluid ounces per 1 minute. And we're wanting to convert this to fluid ounces per... oh, I made a mistake here. So right there, I wrote minutes. That's not what was true. We were told that it was 5 fluid ounces per 1 hour. We want to convert to fluid ounces per minute. There we go. All right, now with that corrected, you're going to notice that we don't have to change the conversion of fluid ounces because we want both of these rates expressed with fluid ounces. But since we're starting off with a rate that's per hour, we want to convert that to per minute. So the blue aspect of this is the only thing that we really need to deal with. So to reconcile with that, we just need to convert hours to minutes. So we just need to know an hour is 60 minutes, of course. So we're going to multiply by a conversion factor. Since hours is on bottom to start with, we'll use hours on top of the conversion factor, put minutes on bottom. Of course, put the 1 in front of hours. Since it's 1 hour is worth 60 minutes. We'll get the hours to cancel out, and then we're good. So we just get 5 times 1 on the top, and then 1 times 60 on bottom, so 5/60. If you reduce that, that ends up being 1/12. So that would be kind of your final answer right there. It just turns out to be 1/12 fluid ounce per minute.